Please.
All righty, everybody.
Just hate it.
What?
Kathleen was just going.
Oh my gosh. All right,
See, we're
so
not the last ones back.
they asked to use the restroom.
Well, it's still not the last ones back.
Okay, so if you guys could get that note sheet out from yesterday, the one we had only done the first page.
Oh my God.
It says 1-9 inverse functions at the top.
I don't know what you said, that's why I said what.
Okay, so this is the one that I'm referring to. Hopefully you have this in your stuff. Okay, so we have already done the first topic that we need to do. Determine if a function has an inverse and find it algebraically. We did that. We are going to flip today to probably my favorite part of inverse functions, and that is the graphing. Okay, so we have some step-by-steps here for how to do the graphing. So first thing we're going to do is we're going to sketch the original function on the graph we're given. If you have different colored pencils, pens, this might be a good time to use them, just so you can differentiate between the original and your inverse. Sure. So we're going to start. So everybody, let's go ahead and we'll graph the line y equals 1/3 x minus 3. Whichever one you like. Okay, so there is my original function graph. You probably have yours. And now, according to the second bullet, all we have to do is swap the x and y in each ordered pair. So if I take the first point that I made, which was at 0, -3, I'm literally going to swap them. And instead of plotting 0, -3, I want to plot -3, 0. So that brings me, oh, I gotta switch colors. I'll switch to red. -3, 0. The next point that I plotted was at, where am I? 3, -2. So I want to switch them and go -2, 3. And perhaps one more is at, what is that? 6, -1. So go -1, 6. When you do that, you should have a perfect reflection of your original graph over the line y equals x. So if you remember from yesterday, that line, or from whenever, the line y equals x, I'm just going to put it as a dash line. You don't have to put this, but it's just kind of neat to see it. That's that perfect diagonal that goes through the origin. Yeah, of course you can. All right, so with the lines, it's not that cool, but when we start graphing some of the more intricate ones, it is neat to see them perfectly reflected over that line y equals x. Okay, let's talk about the domain and range of these. So my original is in pencil here. So what's the domain of this original then? All reals. And what's the range of that original function? All reals again in this case, so this one's not that exciting. And when I did my inverse, so now the red, they're still both all reals, right? But we'll see shortly that the domain and range are actually going to swap with each other when we graph our inverse. So let's try B. All right, so first we need to sketch the original. Where do I even start? What does that look like? Yes, that's an S shape. I literally just plug in points. So if I plug in 0, 0 cubed is 0. If I plug in 1, 1 cubed is 1. If I plug in 2, though, 2 cubed is 8, isn't it? Don't forget you can do negatives, can't you? Of course you can. You can take -1 and cube it. It comes out with a -1. And if you pop in -2, you'll get out -8. So there is my original. So try and make it as smooth of a curve as you can. They're not really supposed to be like jagged lines. Anyway, so there's my original. So now to graph my inverse, I'm just going to swap my x's and y's. So 0, 0 stays right where it is. 1, 1, if I swap 1, 1, do I get 1, 1? That's funny. But now at 2, 8, instead of graphing 2, 8, I want to graph 8, 2. Go to my negatives. -1, -1 swapped is still -1, -1. But then -2, -8, I want to graph -8, -2. And then it might be easier if you turn your paper, make that a nice smooth curve as best you can. And if you're feeling fancy, bless you, go ahead and sketch in that y = x line. Again, you don't have to do that part, but I like to see it. And it sort of is like a double check for me so that I make sure, okay, does it really look like it's supposed to? Am I really reflecting perfectly over that line? That's my goal. And yeah, cool. Look how pretty. Domain of the original. All reals. Or range of the original. Also all reals, so we haven't gotten exciting yet. Same thing's going to happen for my inverse function. Domain and range are all reals. All right, now things are going to get interesting. Let's look at C. So, square root of x minus 2. Remember what the parent function looks like. That's like that slug looking kind of thing. And then what does a -2 in there with the x do the whole thing? Shifts it to the right 2. So your original graph, I don't know. The parent function, if you wanted to graph it, would start at 0, 0, right? And then up 1 over 1. And then I would plug in 4, 2, right? Because the square root of 4 is 2, but I'm going to shift everything to the right 2. So my original is actually going to start here. And then usually when I'm doing this, I just pretend like that's the origin. So that's 1, 1 in my head. And then 1, 2, 3, 4, 1, 2. So here's my original. Now let's swap those x and y's and see where our new function is. So instead of 2, 0, I'm going to be at 0, 2. Instead of 3, 1, I want 1, 3. And instead of, what number is that? 3, 4, 6, 2, I want 2, 6. Oh my, look how nice. Sketching y = x if you feel like it. And I usually do, because I think it looks so nice. Look at that reflection. Oh. Now let's talk domain and range. So ignore everything, just look at the original. What's the domain of my penciled in graph here? The original, what's the domain of that? Braylon, go ahead. Yes. X has to be greater than or equal to 2, right? So either way, it doesn't matter. But that's where my original function is starting. It starts at 2. I have a value there, and then it goes on forever this way. Okay, so there's my domain. What's the range of the original? Cedric, go ahead.
0.
Yes, I'm starting my range. I don't have any y values that are negative, right? And I never will. I don't start having y values until 0, and then I will eventually have everything going up. So I want, if you're doing interval notation, it'd be 0 to infinity, or y has to be greater than or equal to 0. Okay, now look at your inverse function. What is its domain? 0 to infinity. Oops. Or x is going to be greater than or equal to 0. The range, however, is it's the range of your inverse. Yes, 2 to infinity. So you will notice y has to be greater than or equal to 2. Your domain and range will swap between the original and your inverse, which makes sense because we literally swapped x and y. So it makes sense that your domain and range would swap with each other. So if you are able to look or think about what the graph looks like, because remember yesterday we had to like adjust some of the domains to make sure that it fit. In a graph, it's so much easier because if you were to do this algebraically, you'd be squaring both sides. You'd end up with a parabola on the other side, and then you'd have to restrict the domain. But when you're graphing it, it's so easy to see it, right? I wouldn't want this other piece because I don't have that other piece in my original. Okay, last one. Oh, this one's a doozy. You remember what this one even looks like? Jake?
Like a formation of the sea with a canal.
And then this one has
Yeah,
those,
so-
exactly. This one has the asymptotes in it because I'm not allowed to have 3 as part of my domain, right? In the original. So I'm going to start off with a big old asymptote on 3. And I have a horizontal asymptote at what value will I never get out for y? 0, yeah. So these are my 2 asymptotes. And then it's really just that parent function shifted to the right 3, right? So I have a dot there, and then these just get closer and closer and closer to the asymptotes, but never actually touch it. Same thing's happening here. Okay, I'm actually going to, I think it's going to be easier for us to, when I go to do my inverse, where my 2 asymptotes meet right now is at the point 3, 0. So my new point where the 2 asymptotes are going to meet in my inverse, wouldn't that be 0, 3? So at 0, 3, this is going to be where my 2 asymptotes meet. So let me use another color. I got blue here. Then I will use. Let's try, oh yeah, I've been using red. So now in my, I mean, you could go point by point too. I was at 4,1, I'm at 1,4. So this one should come this way. This one was at 2, -1, so I want -1, 2. And this one will come this way. And I know it may not look like it at first, but believe it or not, these really are reflecting over the line y equals x. I'm just gonna pop that in. How cool. Oh my gosh, imagine the designs we could make with this. What will your next extra credit spider look like? I don't know. How cool. Thoughts? We feel all right? Let's talk domain and range. So my original. What was the domain of the original? X could not be 3. Correct. Y could not be what? In my original. 0, right? That's where we had that other asymptote. So now in theory, they should switch. Let's see if it really does according to my graph. Let's see, my x's, yeah, I'll never have an x at 0. So my domain x cannot equal 0. And for the range, yep, I'll never get one at 3. Y cannot equal 3. Pretty neat, huh? I knew you'd like that. So to practice these skills, I do have, let's see what I want to do here. I might just give you the other sheet that I have. Okay, your homework is going to be in 2 parts, but they're both relatively fast. So the first part, you want to start it right now, is the just the back of last night's homework. So you've got 6 of them there to try. And then I'll give you the second piece.